In this video, I introduce MetaICL, Learning to Learn in Context. MetaICL is a meta-training framework for few-shot learning, where a pre-trained large language model is taught to do in-context learning on a large set of training tasks. Meta-training enables a large language model to effectively learn a new task in context at inference by conditioning on a few training examples without parameter updates or task-specific templates. Fine-tuning large language models requires updating the parameters of pre-trained models, which is impractical in many applications, as shown here. However, in-context learning, like zero-shot, one-shot, and few-shot learning, performs the new tasks with only forward passes at test time without backpropagation and gradient computation, as shown here. MetaICL trains a large language model on a collection of tasks, which is similar to multitask model training. For each iteration, one meta training task is sampled, and k+1 training examples x1, y1 to x k+1, y k+1 are sampled from the training examples of the chosen task. MetaICL uses the concatenation of x1, y1 to yk x k+1 as input to a language model, and trains the language model to generate yk+1 using a negative log likelihood objective, namely maximizes the conditional probability of output yk+1 as shown here. MetaICL simulates in-context learning at inference, where the first key examples are used as training examples, and the last example is regarded as the test example. MetaICL reduces the burden of downstream tasks to use a pre-trained large language model, but increases the training time of a pre-trained large language model. In addition, the meta training only enhances the chosen tasks. However, the true purpose use the knowledge learned by a pre-trained language model to fit a new task. For more details, please check with these references. Thank you. Bye.